Hey everyone, thanks so much for coming to my talk on full stack Scala development with Zio. How many of you have heard about Rock the JVM? Can you raise your hands? Oh my god, this is beautiful. All right. I'm really thankful and I appreciate you following my work. I'm really privileged to be able to skip this introduction in this case. So many of you know me as the voice of Rock the JVM, so I'm going to get into my persona mode like, hey everyone, this is Daniel for Rock the JVM and you are watching full stack Scala development with Zio. If you have any questions about this talk or my work at Rock the JVM, you can find me at Rock the JVM on LinkedIn and Twitter and YouTube. This is where I'm most active. And you can hit me up at daniel@rockthejvm.com if you have any questions about my work in the Scala world at daniel@rockthejvm.com. So, but I'm not here to talk about myself. I'm going to talk about my billion-dollar startup idea. Hear me out. How many of you have heard about Trustpilot or Glassdoor? Raise your hands. All right, so this is pretty much everyone. Hear me out. Glassdoor for Scala companies with AI. Yeah, this is what I made. This is the Rock the JVM companies board, which is like a Trustpilot or a Glassdoor for Scala companies with AI integration. This is actually live deployed at this website, companies.rockthejvm.com. I took the liberty of adding my own company there, Rock the JVM. Like, you're looking at it. I am that company. You can also add Zyverge or your own company in that. You can actually play with this app. I made it for my latest course, which is called the Zio Rite of Passage. This is a full-stack Scala application, Scala 3 application with the Zio stack with all the features that you see here on the screen, which is the regular CRUD that you see in many other applications of this scale. Full user management with one-time passwords delivered over real emails, credit card checkout with Stripe, AI integration with GPT-4, and lots of other goodies. This is based on Zio. So we have Zio for everything. We use a bunch of Zio libraries like ZioJSON, ZioConfig, ZioTest, ZioMock, ZioStreams, test containers, and a bunch of other libraries based on Zio, like Quill and ZioHTTP with Taper on top of it. And also using some other tools wrapped in ZioFX like Stripe, Stripe integration, GPT-4, Auth0 for authorization and authentication, and FlyawayDB for schema migrations in case you need to add new features or change domain models. Now, I'm not going to talk about the app too much. The app is right there. If you want to play with it, you can do that. You can do that right now. And I teach it on camera. So I built it myself. I write all the code from scratch. I deal with errors myself. I say, God damn it, on camera. If I get into errors, I'm fixing them myself so that you can feel what it's like to build this sort of app yourself. Now, the goal of this talk is for you to get some sense of what good practices are, some architectural decisions that you can also embed into your own applications. So I stacked this backend in layers. Now, many layer kind of architectures start with layers at the bottom, but I don't like that. I start with layers at the top because that's what the user sees. So my first layer is what the user sees, the thing that you can build a UI on top of, that you can build APIs on top of, and that's the HTTP layer. So I define endpoints with Taper. What you see on the left is the two flavors of endpoints that I use in this application, and there are secure and unsecure endpoints, so that you have privileged and unprivileged data that you can see in the application. For example, the ability to post a company is just restricted to authenticated users. So the definitions that you see on the left are the two flavors, and the definitions on the right are expanded definitions of those two flavors with details such as tags and names and whatnot so that you can generate Swagger interpretations on top of them. And you can also define inputs and outputs so that you can get a type-safe endpoint definition. Now, this layer is just the HTTP definition, and this is what the front end also calls. So I defined them in very abstract terms, and I'm using full stack so that these things are available to both the front end and the back end because the front end will just invoke these things as functions. So I'm going to deal with that a little bit later. Layer 2, below that, is the server implementation. So the implementation of those endpoints contains two major things. One is the potential security definition, or the security check for a user to be authenticated, maybe the JWT token that the user passes automatically as an authorization header in HTTP can be validated for permissions, for roles, so you can get elevated privileges depending on who you are. As well as, and this is the second part, the server logic, which usually delegates the business logic to an underlying service. So the last line that you see at the bottom is the service implementation or the service call, and this is my server implementation for the HTTP endpoint. Now, the nice thing about these controllers, we call them, is that we hide constructors so that in the big HTTP API, I'm not building these things myself, but I'm exposing smart constructors. But in the context of Zio, smart constructors aren't just apply methods and companion objects. They're effectful constructors because these things can allocate resources and invoke configurations and whatnot. So the smart constructors are Zios. So this was layer 2. Layer 3 is the core business logic of the application. So this will implement the core functionality of what it means to log in, post a review, invoke OpenAI, pay, whatever. So this is a service example, which is defined as a trait, and you can swap implementations as well at your will. And these are instantiations of the services that we define as traits with the dependencies that you see as constructor arguments. And this is an example of what it takes to make a summary. This is just composition of Zio effects doing a bunch of things. For example, I'm getting all the reviews and putting up a prompt for GPT-4 and sending that and expecting a response so that I can return that to the UI. These services are also instantiated not necessarily as directly with constructors because I also make them private, but I expose smart constructors, in this case, not as a Zio, but rather as a Zio layer, because these services can talk to each other and they can be passed as dependencies to one another, which is why I'm exposing this thing as a layer. One or more layers, in fact, because some of these services can also take configurations, and configurations can be passed or created selectively with this sort of call that I've made a little mini framework in the app to create configurations selectively and push those into the dependencies of the layer of the service that I want to build. So that was the service layer. This is the core business logic, and this thing can take configurations. They can talk to other services and whatever. The layer below that is the data persistence layer, which is the repository. This repository is a database API. So I define a trait with a bunch of methods that I care about, and these things are implemented as quill effects. So this is one example. I was describing just one of vertical with reviews with all the layers here. And this layer with the repository generates a type-safe query with quill. So this thing with run and lift and whatever, these are functions that quill supports, and they are parsed by the quill library via macros, and this will generate a type-safe query that you can see here in the comment. So that little line is translated to a type-safe SQL query that you see in the comment. This thing is also instantiated as a Zio layer because due to the fact that this is the layer at the bottom, this is passed as a dependency to the services that may use this layer, as well as the other endpoints or other modules in the application. So this is passed as a Zio layer. This constructor is private, and we expose a smart constructor in the form of a Zio layer. Now, this architecture is kind of a layered architecture that is very similar to the onion architecture, and every vertical has a similar onion. But this also has some of the features of the hexagonal architecture. So an onion plus the hexagonal architecture, onion plus hex, I call that onion X. So the onion with the layers segmented and with the verticals independent, so this looks like a pizza, where the domain model sits at the core. On top of that, we have the repository, which is the persistent and data storage layer. On top of that, we have the core business logic. And on top of that, we have the user-facing HTTP API. So the onion architecture is nice because you can swap the outermost layer while keeping the layers underneath intact. So for example, the HTTP API will allow some high-level actions for potential users. For example, I want to log in, or let me put up an authenticated HTTP request to fetch some data from your application. So the ability to log in can be very easily swapped with a testing user-facing API, or something that allows an external user to consume data from your application. Like, here's your API key. You can just use the backend without necessarily having a UI. So this onion architecture allows us to swap the outermost layer very easily while keeping the layers underneath intact, and this allows for extra modularization. Now, when you strip away the outermost layer, the rest of the onion has the same property. So for example, this core module can also be swapped with a testing core module, which is, I don't know, maybe something that tests the underlying layers. So the rest of the onion will still have the same property. So you can think of an onion as the recursive version of this architecture. Now, in this application, the onion architecture doesn't necessarily have all the layers because, for example, if you're using an external service like Stripe for credit card checkout, you don't necessarily have a domain model of your own because you're using an external service, which is why on this diagram here, the domain model, the blue circle, is missing. So we have the payments core infrastructure, then we have the payment service, which uses the Stripe API, and maybe I want to expose some HTTP endpoints on top of that, such as a promoted or a paid endpoint, or a webhook for Stripe to hit back to me when the credit card checkout has been fully successful. So this is the aspect of the application that's most similar to Onion. The hexagonal architecture also is present here in the form of this ports and adapters pattern. I've never really understood why the hexagonal architecture is called the hexagonal architecture. The hexagon didn't really make sense to me. But this is the general diagram that we see in the hexagonal architecture. And the idea behind that is that the core business logic sits in between the user-facing potential actions, like the ability to log in, and the actual effects that are being executed in the real world. So for example, some payment is being made. GPT-4 has been invoked. Something has been stored in the database, and so on and so forth. So the core logic, the service layer, is the API by which, or on top of which, you can build other APIs, and the core business logic can also stay the same while performing different effects in the real world. So this is why I call this OnionX, because it mixes the concepts of onion with some concepts of hex without extra ceremony. Now, this architecture is particularly well suited with Zio because in these layered architecture, you can plug in all these layers automatically and everything just works. So I call this ZOnionX, if you want to look at it like that. So onion with layers segmented, hex without the ceremony, and everything with Zio. So the nice thing about this, and this is one of the superpowers of the Zio library, is that you can plug in all the layers that you need automatically, and Zio figures out which layer fits into which dependency. So I don't have to pass all the layer dependencies myself. I don't have to pass configurations top down, so parse in the giant configuration file, strip out the pieces, and plug them into the layers and whatnot. Zio does that automatically by this graph. So congrats for the Zio provide function, because this is super magical. So this is very easy to configure selectively because some services may take configuration, and every service has its own configuration, which is why what you see here on screen, if you look at the services section in the provide function, many of these services, most of them, almost all of them really, have a configured layer. So every service has its own configuration, and I can build that selectively. I don't have to parse the configuration file myself at the beginning of the application and push that downwards. I don't have to do that. So this frees up a lot of mental burden for me, and I'm really happy about that as a developer. Now, the not so nice things, and this particular architecture needs some discipline. So this is the major, let's call this hurdle that you have to go through, and this is one of the reasons why I made this course, is that such discipline can be natural, habitual. So you have to be careful, for example, with error management, because it's very tempting to just use any in the error type or just use Zio tasks and throw runtime exceptions. But you have to be really disciplined on how errors are being thrown and managed. Congrats for the previous speaker with the tracing. That's super helpful. So you have to be disciplined about that. You have to be disciplined about the type inference as well, because I personally, and I showed this on camera, for Taper endpoints, for example, if you pass in too many inputs, the type inference, because Taper has like 5 or 6 type parameters, some of which may be covariant, some of which are higher kinded, type inference can be pushed to its limits, and you kind of have to know at some point, you have to kind of know what types you expect. So type inference can also be a problem. Manual intervention in layers, if you want to build layers and map these layers yourself, that sometimes can explode your code, which is why this provide function is really magical, because you don't have to think about these layers too much. And sometimes the rules, for example, in Quill, are a little bit rigid, and personally, while trying to do a little query that matches arrays and does array overlap. That's not really supported in Quail natively, so I have to kind of hack my way through something that Quail could parse and to not throw a stack and line overflow error in my face. So sometimes you kind of have to play by some, let's say, a small set of rules so that your application can work. But that's about it. On the front end, we have the amazing Laminar library. And Laminar is very nice for building reactive front ends. And we integrate this with Zio with a little mini framework that I build in the course. Laminar is great for pure functional programming and functional reactive programming so that you can decouple the state of your application, which is the reactive variables, from the actual UI that's being displayed on the screen. The general principles of Laminar can be learned in just a couple hours, and I'm going to talk about them right now. So Laminar has two sets of, let's say, things to take care of. One is the actual UI that you render on screen, and one is the logic of the application. The logic of the application actually belongs to a different library, which does the functional reactive programming model. It's called Airstream. And in the reactive variables, you have the concept of events. And these events are generated, are emitted. And based on those events, you can render things on the screen. So you have 4 types of reactive variables. One is called event stream, which is a sequence of events that are being pushed to you, so you listen to them. One is a writable bus of events, so you can push events to that and make other things listen. You have the concept of signal, which is an event stream with a current event or a current state, so it's a stateful reactive variable. And a var, which is a pure reactive variable that is both readable and writable. So you can update the variable with just setting a new state. So that's one section. The other section is the UI, and Laminar has wrappers for all the HTML tags. And for every HTML tag, you have what's called a modifier. Every tag has a modifier, or can be plugged in with multiple modifiers. And everything is a modifier. Everything meaning a CSS class, an on change, an on click, or on input, or on anything event. Reactive children, such as the thing that you see here on screen with children with left arrow. So that means that I'm listening to the changes of the status variable, which also depends on another reactive variable. And when that status changes, I may render different things on screen. So it's very easy to decouple state management, which are these reactive variables, with what's being rendered in the UI. So it makes app development quite much easier. We also have what is called an on-mount callback. On-mount callback allows us to trigger something when this particular HTML tag is being mounted in the DOM. So I can trigger a use backend. This use backend is just my mini framework that I reduced to a single function that will allow me to call the getById endpoint in Taper. So I'm using a Zio effect in there, and that Zio effect, when finished, pushes its value to a reactive variable in Laminar. So the mini framework that we built in the course is something that integrates any kind of Zio effects, and when they finish, you can push their values to the reactive variables in Laminar. Now, some memorable moments that we had in the course is this Automagic dependency injection where you can just plug in all your layers in there. If you have a new dependency, this provide function is absolutely fabulous. It gives you the exact thing that you need to plug in, or it also gives you a warning if you're plugging in too much. So this is magical. I talked about this a little bit earlier. One is selective config. So this is my attempt to generalize configurations so that when I build a layer in one of my services, I can just make a layer with the appropriate data type, and I plug that into my little layer as a dependency. So this last line is let's say, a great mental burden reliever, much like the provide method that I talked about earlier. Zio on the front end is also very nice because this mini framework allows me to use the Taper endpoints that I define on the back end with the exact same definitions on the front end. So if I happen to change the API in my back end, the front end is completely up to date with that. And if I happen to have any input changes or any data structure changes, that domain model is put into a common project that is both made visible for the JVM project on the back end and on the JS on the front end. Wrapping Java APIs is also a particularly satisfying thing. So this is very readable for us as Zio programmers. And Stripe is also really easy to integrate with our Zio application. So this, what you see here on screen, is half of the Stripe integration. So just imagine 2 times this slide, and you have Stripe integration into your app. And I found this quite satisfying. So I talk about all of these architectural decisions and all these best practices. I use them on camera, and I deal with the problems myself in this little course that I made, which is called the Zio Rite of Passage. So this is a project-based course in Scala 3 with the Zio stack with Laminar on the front end, where you can build this exact product that you're not afraid to, that are not ashamed to deploy as your own thing. So you can build your entire product on the Zio stack, and you can use this product for actual users. Special thanks to Mark Rudolph. If you're watching, thank you so much for scaffolding the initial sketch of the project that later became, like a year later, became this course. And at Fellow Noodle, my cousin Antonia Avram, for creating this absolutely amazing banner for the course. So thank you so much for coming to my talk. I'm here to take any questions.